In this video, we're going to have a look at the multiple choice from the NESA Sample HSC Mathematics Extension 2 exam. Now, the sample exam that we're looking at is slightly different to the one that was put out earlier in the year. It has more questions, and some questions are the same, some are a little bit different than the ones that were in the previous sample exam put out. Now, this is actually my first time having a look at this exam, so my solutions are sort of going to be my raw solutions. But hopefully there won't be any mistakes. Hopefully you get a bit of an insight into how I think when I look at a question, what are the first things that go through my head, and so on. So without wasting any more time, let's get straight into the multiple choice. Okay, so the first one, which expression is equal to this integral, the integral of x squared sine x? So immediately I'm thinking, let's use integration by parts because there really isn't another way of doing it. And I'm going to choose u to be x squared. So u dash is 2x, v dash is sine x, and v is going to be the integral of sine x, which is minus cos x. Don't forget that minus sign. So our integral is u times v, so minus x squared cos x, minus the integral of, let's see, u dash times v. So 2x times negative cos x. Well, that negative and negative gives us a positive cos x dx. And so our answer should be C. That looks like it matches up. Okay, which of the following is a primitive of sine x over cos cubed x? All right, so what we want to do is we want to integrate this thing. We want to integrate sine x on cos cubed. Now, I'm going to split this up as sine x over cos x times 1 on cos x. Sorry, 1 on cos squared x. And the reason I do that is because this will give me a tan times sec squared. And if I can get a tan and a sec squared, I know that tan and sec are related in a lot of ways. They're related through that identity, 1 plus tan squared equals sec squared. So maybe let's write that on the side here. 1 plus tan squared equals sec squared. Don't know what's going on with the iPad. Tan squared equals sec squared. And I know that they're related in a lot of ways with calculus. And that's what we're doing. We're using calculus at the moment. So I'm thinking that we can integrate this by using the reverse chain rule. So I can see that this here is f of x, and this is f dash of x. So if I wanted to, I could make a u substitution, u equals f of x, but I don't have to do that. I can use the reverse chain rule and I would get tan squared x on 2. Now when I look at my options, this is something that's interesting actually. We don't have any tan squared functions in our options here. There are no tan squareds. And that's okay, because we could have integrated this in another way. Well, okay, that's zoomed in a lot for no reason. Let's move down here, and let's think about this integral, and let's rewrite it as tan x sec x times sec x dx. Now again, I'm still going to use the reverse chain rule. I've got some function, g of x, I'm just going to call it g, but our function is sec, and the derivative of sec is sec x times tan x, which is exactly what I've got here. Okay, and so if we integrate this, we raise the power of our function by 1 and we divide by the new power. Okay, so this looks a bit strange because both of our integrals, we've done everything correctly, but it looks like they're different. We've got tan squared x on 2 and sec squared x on 2, and those are clearly not the same thing. But both of our methods are correct. So what's going on here? Well, these two are actually correct. Both of them are correct. But the reason that it looks like they're different is because we're not putting our plus c's. And that's really what makes these two functions equal, because I'm going to substitute 1 plus tan squared for sec squared here. So I'm going to do that in green. I'm going to get 1 plus tan squared x over 2. And then let's continue in orange, plus c. And I'm going to split that up into 1 on 2 plus tan squared x on 2 plus a constant. And now what do we have? We have got our tan squared on 2 reappearing, which matches up here. And then this half gets absorbed into this constant here. So really this is just tan squared x on 2 plus some other constant. Okay, but we'll just call it c anyway because it doesn't matter, it's just a constant. But the idea is that these two answers, well, I suppose we have to include the plus c, these are actually exactly the same thing. And the idea is that it's the plus c which makes them the same. But the question doesn't ask for the primitive function, it asks for a primitive function. Now, a primitive function means we could have had any constant that we like, so we're just going to choose c equal to 0, which is going to give us exactly option A. Okay, so our answer is A in this case. Now, obviously, all that explanation that I did, I wouldn't be thinking all of that in an exam. I would just try to get to the answer, which we did get to the answer. We got to it here, and then that's it. But I'm just adding this in sort of for a bit of completion, a bit of understanding while we're doing the questions. Okay, the Argand diagram shows the complex number e to the I theta. All right, which of the following diagrams best shows the complex number minus I e to the minus I theta? Okay. Interesting. Now, there's two ways that we could go about doing this. Maybe we'll do both, again, just for completion or just for understanding. The first is I would look at how would I transform this function or this complex number to get to this complex number. Okay. Now, if I start with e to the I theta and I do some transformation to get to the e to the negative I theta, what I'm actually doing is I'm reflecting this across the real axis so that I would end up at somewhere about here. So this is e to the negative I theta. And then the next thing, I want to go from e to the negative I theta. I want to transform that to get to minus I e to the I theta. Now, multiplying by I, what does that do? Multiplying by I rotates our vector anti-clockwise by pi on 2 degrees. But we're not multiplying by I, we're multiplying by negative I. So that's going in the opposite direction. That means we're rotating clockwise by pi on 2 degrees. So I'm going this way by pi on 2, which means my vector should end up looking something like this. E to the negative I theta, we've multiplied it by negative I, and this should be a right angle here. So you can see that the only option that's sitting in the second quadrant looks like A. So A should be our correct answer. Now, what's the other way of doing it? Well, let's change color. The other way that I can think of is instead of starting with e to the I theta, we're actually going to start with negative I. So where does negative I live? It lives, well, somewhere here. And then we're going to just multiply by e to the negative I theta. Now think about it. What does multiplying by e to the I theta do? Pardon me. I have a bit of a cold at the moment, so apologies for any coughs or weird nasally voice. What does multiplying by e to the positive I theta do? It rotates our vector anti-clockwise by an angle of theta. So if I multiply by e to the negative I theta, that's going to rotate our vector clockwise by an angle of theta. Now you can see that our angle theta is this much. It's a little bit greater than pi on 2. So if I want to rotate my green vector, it's going to be more than pi on 2, a little bit more, and we get to the same value. Okay, so that's another way that we could think of this. So I suppose this angle in here between negative I and negative I e to the negative I theta, that angle should be theta in there. Okay, but again, we get to A, which is good. We've done it in two ways. We got the same answer. It's sort of a bit of a confirmation for us. All right, this looks interesting. Given that x and y are integers, which of the following is a true statement? Okay, for every x, there exists a y such that y squared equals x. For every x, there exists a y. Okay, so the key bit here is this word, integers. X and y have to be integers. Now we can easily come up with a counter example for the first option here. What if, so it says for every x, so let's pick an x. I'm going to choose x to be equal to 5. Okay, so for every x, in our case we've chosen x to be equal to 5, there is some y value such that y squared equals x. So there has to be some y value such that y squared equals x, and in our case x is equal to 5. But if we were to solve this, we know that the solutions are plus or minus root 5, and we can see that this clearly is not an integer value for y. So we've already come up with a counter example here, and so that's going to be wrong. Option B, for every y, there exists an x such that y squared equals x. Okay, so for every y, let's just pick a y. So let's say y is equal to 7, I don't know, any number. Now it's saying that there should be an integer such that 7 squared equals x. So there should be some integer value for x. And we know that there is an integer value for x here. That's clearly just 7 squared, it's 49. Okay, 49 is equal to x. So this one looks like it's going to be correct. So I'm keeping that in the back of my mind. If I quickly check the next two, for every y, for every x, y squared equals x. Well, that's not true. If it's for every y, we can pick any y that we like. So let's pick 5. And if it's for every x, we can pick any x that we like. Let's also just pick 5. Why not? It could be any number. And this is saying that 5 squared, which is y squared, equals x, which is also 5. Clearly that's not true. And then for D, it's the similar sort of nonsense, right? We can just pick x equal to 5. This time maybe let's pick y equal to 3. Who knows, why not? And it's saying that 3 squared would have to be equal to 5, which is clearly nonsense. Okay, so D's wrong. B would be our correct answer. Okay, a particle is moving along the x-axis in simple harmonic motion. The displacement of the particle is x meters. The particle is at rest when x equals -2 and when x equals 8. Okay, so before I continue, we know in simple harmonic motion that our particle is at rest at the extremities, at the endpoints of our motion. So if we were to draw the motion, we know that our endpoints are -2 and 8. And so our center would have to be halfway between the two, which is 3. Okay, so this is our center of motion, 3. And then what does it say? It says it takes 6 seconds to travel from x equals -2 to x equals 8. Okay, what is the maximum speed of the particle? All right, now, when I do this question, I already know a few facts about simple harmonic motion, and one of them is that the maximum speed is a times n. And you can actually prove this or convince yourself of this by just thinking about this formula. V squared equals a squared, n squared minus x naught squared. Okay? Now, the maximum speed is dependent on wherever our particle is, but we already know, if we understand simple harmonic motion properly, we know that the maximum speed is going to be at the center of motion. So max speed is when x equals x naught. All right, and that makes sense because we're taking this value off, and if we want to make our whole thing maximum, we want to take off as little as we can. And so the smallest we can make that is 0. Okay, and so that means that our V max would be a squared into n squared minus 0, which is a squared n squared, and so V max equals a times n, okay, which is what we just said up here. Now this is a good fact to have in the back of your mind, so that if something like this pops up in a multiple choice where you don't have to show working out, you can use the fact straight away and it will help you to get your answer. So what's A? A is the amplitude, and N is what we call the angular frequency. Now, what is A? In this question, A is the or in any question, A is the distance from the center of motion to the extremities. In either direction, it doesn't matter because it's still a distance. So in our example, or in our question, A is equal to 5. Now, what about N? What is N? How do we work that out? Well, we know that N equals 2 pi on t, on the period. Okay, now what's the period? Well, the period is how long it takes to get from one point on your curve back to that point. Now, we know it takes, from starting at -2 to get to 8, it takes us 6 seconds, and then to get back, it would also take us 6 seconds. So the total period would be 6 plus 6, which is 12. So we know that, maybe let's write it here, the period is 12. Okay, so we can substitute that into this. We get 2 pi on 12 equals pi on 6. And so this is going to be 5 times pi on 6, which is 5 pi on 6, and that is one of our options. That's A. So in this one, it would have been really helpful for us if we knew this fact, that the maximum speed is equal to A times N. You could also try to prove, it's not part of this question, but that the maximum acceleration is going to be equal to A times N squared. Okay, that's another fact that would be helpful to have in the back of your mind, and also would be helpful if you try to prove it to see where it comes from. All right, number 6. The sign shown appears on the rear of large vehicles. Okay, if you can't see me, if you can't see my mirrors, I can't see you. Okay. And then it's going to say which of the following statements is logically equivalent. Now, typically with these questions, they're testing if you know what contrapositive is. So I'm already anticipating using the contrapositive. But let's try to identify what our P and our Q is. So this is like saying, if you can't see my mirrors, then I can't see you. Okay? Now the then is the implication sign. So let's write this. If you can't see my mirrors, then, or the implication sign, then I can't see you. So this first bit here is like my P, and I'm going to do this in purple. This is like P. And then this statement is like my Q. It's my second part of the statement. So P implies Q. Now the contrapositive tells us that we should be looking for not Q implies not P. Okay, there's a few different ways that you can write not. I'm just used to writing it with an exclamation mark, but do whatever makes you feel comfortable. So what is not Q? I can't see you. I want the opposite of that. So that would be I can see you. So I'm saying I can see you implies not P. If you can't see my mirrors. So P is the statement that you can't see my mirrors. Not P would be you can see my mirrors. You can see my mirrors. So I'll be looking for that in our options. If I can see you, then you can see my mirrors. Option B looks good. Okay, so this is by the contrapositive. I would really expect a contrapositive question to pop up in multiple choice because it's an easy thing to assess in multiple choice. Which of the following diagrams best represents the solutions to this equation? Okay, now out of experience, I know what these kinds of questions look like. And the idea is that we want to write this as arg of z, but I'm going to be a little bit picky with how I write it. I'm going to write it as arg of z minus 0 minus arg of z minus -1 plus I is equal to 0. So I've brought this over to the other side, and then I've sort of factored out a -1 here. And the reason I do that is because I know that this is going to be something that's related to the complex number 0 and negative 1 plus I. And if I look at my options, this has this one here, and also, so the first two, A and B, they're not looking at negative 1 plus I, they're actually looking at 1 minus I. So I'm going to cancel those out already. I already know that those are wrong. And now the question is it the line segment between the two, as in option C, or is it the one that's outside of the two? And the answer is it's going to be the one outside of the two. And the reason is because we want the arguments between the two numbers to be, or between the two, to be equal to 0. If I'm at some point in here, the arg is not going, it's actually going to be pi, it won't be 0. Okay, so that's why the answer in this case is D. There is a video that I made a while ago about this concept, and I would really recommend that you go and have a look at that video if you're not 100% sure about this question. Okay, let's see. A particle is moving along a straight line. Initially, so when t is equal to 0, its displacement is at x equals 1. Its velocity is 2, and its acceleration is 4. Which equation could describe the motion of the particle? Okay, well, let's substitute in these values. Yeah, let's substitute in these values and see if any of these check out. So in the first one, we should get 2 equal to 2 times sine of 1 minus 1 plus 2. Now sine of 0 is 0, so this actually looks like it checks out. But let's confirm that the others don't work. Okay, in this one we have 2 equals 2 plus 4 log of 1, which, well, log of 1 is 0, so this actually also checks out. Okay, so there's probably going to be some other way to separate those two. Let's keep going, we might be able to eliminate something. V squared. So here we have, subbing in V is 2, gives us 4, equals 4 into 1 squared minus 2. So that's negative 4. Okay, so this one's not correct. We can eliminate that one. And also subbing into here, we get 4 equals 1 plus 2 times 1 plus 4. Okay, that one's clearly not right as well. So now we need to work out which one of these is correct and which one is not correct. I'm going to just remove these now, just to give myself a bit more room. I'm gonna go on the fact that we need to somehow use the acceleration, because otherwise, what was the point in giving that information? Now, our functions are v in terms of x, and hopefully you're familiar with acceleration is dx on a half v squared. Okay, I think we're going to have to make use of that. So let's do it for the first one. This does look like it's going to be a bit painful, and it does look like I'm taking a long way for a 1 marker, but I can't think of anything else at the moment, so I'm just going to run with it. V squared, so that's going to be 2 sine of x minus 1 plus 2 squared. Okay, we can pull out the half from the derivative, and then we're going to use the chain rule. So bring down the power, 2 sine x minus 1 plus 2, multiplied by the inside derivative, which is, let's see, 2 cos of x minus 1. So that's our acceleration. We can see that 2 and 2 cancel as well. Okay, this looks interesting. When x is equal to 1, our acceleration is 2 sine of 1 minus 1 plus 2 times 2 cos of 1 minus 1. Now this term becomes 0, and so I get 2 times 2 times 1. So this is actually 4. So this one looks like it's going to check out. But let's just confirm that B is also incorrect. A is correct, but let's check that B is incorrect. I might do it in a different color. Okay, again, we're going to use d dx of a half v squared. Okay, so d dx of a half 2 plus 4 ln x squared. If I differentiate that, what do I get? We can pull out the half times 2 4 log x times the inside derivative, which is 4 on x. And when x is equal to 1, the acceleration, we can see that these cancel. We'd get 2 plus 0 times 4 on 1, which is 8. So this is not correct. B is not the correct answer, and A is the correct answer. So that one, maybe there's a quicker way of doing that, and if someone does see a quicker way, please let me know in the comments, because that's quite a bit of work for just 1 mark. Okay, this looks interesting. It is given that A, B are real and P, Q are purely imaginary. Okay, which pair of inequalities must always be true? Wow, okay. This looks very interesting because we're dealing with complex numbers, but we're also dealing with inequalities, which we know is something that we can't really do. We can't really work with complex numbers and inequalities because the complex numbers are not ordered. Okay, how would we go about this? Well, the first thing I think I'm going to do, I'm going to write P is equal to I times some letter. Let's just call it R, where R is a real number. And likewise, Q is I times S, where S is a real number. So that's now all I've done is written this statement in another way. Okay, that's what it means to be purely real. I times a real number. Purely imaginary is I times a real number. But how do we involve inequalities now? This looks like a challenge. Honestly, if I was in an exam, I would probably skip this and move on because it's not coming to me immediately. But I'm going to play around with it. Now, this sort of thing looks a lot like what we do with our inequalities, our regular inequalities, when we're dealing with x minus y squared is greater than or equal to 0. So I think that's probably going to be my starting point. But I need to, that only works if we're dealing with real numbers. So, I'm going to look at A times R. Yeah, I think this is going to work. I'm going to look at A times R minus B times S. Now, the reason I can do this and say that this is greater than or equal to 0 when I square it is because A, R, B, and S are all real numbers. So I can say since A, B, R, and S are all real. So let's go ahead and square this. So we get A squared, R squared, minus 2AR. I'm going to write them actually in order. So AB RS plus B squared S squared is greater than or equal to 0. And I'm going to move this over here. So I get A squared, R squared. I think I can see it now. Wow, this is a really good question. Really, really good question. Yeah, wow, this is a good one. Okay, I'm going to move this over here just to make some room for myself here. Okay, now I'm going to have a look at what happens when I square each of these terms, or these equations. So I'm going to get P squared equals I squared R squared, which means P squared equals minus R squared, and Q squared equals I squared S squared, which is Q squared equals minus S squared. Now, the reason I'm doing that is because in my working out so far, I've got R squareds and S squareds, and I somehow know that I want to get P squareds and Q squareds. So I need to substitute that in, but if you notice, we need to have a negative, sorry about this, I'm just looking at this question and thinking how good it is. We need a minus r squared and a minus s squared. So what I'm going to do is I'm going to multiply this bit of my working out by -1. I'm going to multiply this inequality by -1. And be sure that when you do that, you swap the inequality sign. So I have minus a squared r squared minus b squared s squared is now less than or equal to negative 2ab rs. Okay. Now how does that help us? Well, I'm going to write this one more step a bit explicitly. Minus s squared. And then this -1, I'm going to write that in a different way. I'm going to write that as I squared. Now, if you're getting a bit uncomfortable about having complex numbers in inequalities, you're not the only one. This looks very strange to me. However, it is not actually a complex number. It is really a real number, right? It's -1. But the advantage of this is that I can split this up now if I want to, and I'm going to just write it on the side here maybe. I can write this as 2ab times IR times IS. And then IR is the same as P, that's from up here. So this is P, and IS is the same as Q. And actually it looks like we've got our answer, because we know what negative r squared and negative s squared is. That comes from over here. So what have we got? We've got, let's do it in blue to keep consistent, a squared times minus r squared, which is p squared, plus b squared times minus s squared, which is q squared. And we've already seen that our right hand side is 2ab pq. Okay, so that looks like these options are out. Okay, so now we need to have a look at A and B and distinguish between these ones. And we can see the only difference is the direction of the inequality sign here. All right. Now, again, if someone sees a quick way of doing this, because I'm doing a lot of work for just 1 mark, please do let me know in the comments. So now we want to have a look at a squared b squared plus p squared q squared. We want to work with that. And I think, once again, instead of p's and q's, I'm going to use the r's and s's. And somehow, hopefully, once we do a bit of working out, we'll be able to involve the i's, or involve some negatives, which will bring in i's. I'm going to do this in a different color. Whoops, that's a highlighter. I'm going to do this in a different color, just so I don't get it confused with the previous working out. So I want to have a look at AB minus RS squared. Again, we can say that this is greater than 0 because they're all real numbers. And let's expand. We have a squared b squared minus 2ab RS plus r squared s squared is greater than or equal to 0, and we move that over. We get a squared b squared plus r squared s squared is greater than or equal to 2ab rs. Now this bit looks fine actually. Yeah, this looks good because we can substitute in r squared equals negative p squared here, and s squared equals negative q squared, and then we have a negative negative, which gives us a positive. But the problem looks like it's coming from here, because when I substitute in r and s, right, let's write what r and s are. R is p on, or not even write r and s separately, let's just combine them. R times s. That would be p on I times q on I, which is an I squared in the denominator, so negative 1 in the denominator, which is negative PQ. So that doesn't look good, but I think we have a fix for this, because we can just, let's use an orange here, we can make this a positive. And then when we bring the positive over to this side, it actually becomes a negative. Yep, and that looks like it's going to work because now we can substitute in everything, all our values for r squared and s squared, and our values for r times s. So r squared, let's write it explicitly, r squared is negative p squared, s squared is negative q squared. If we put that in, I think we get our answer. So r squared is the minus p squared, s squared is minus q squared, and we can see that that's going to give us positive p squared q squared. And then this is minus, the one in orange, 2ab negative pq. And if we tidy everything up, we get a squared b squared plus p squared q squared is greater than or equal to 2ab pq. Wow, what a question. That gives us option B. Holy moly, that is a really difficult question for a 1 marker. Surely there has to be something easier than that I'm just not seeing. Wow, okay. Anyway, let's move on. Last question. Which pair of line segments intersects at exactly 1 point? Okay. Okay, first thing I noticed when I look at this question is that I can eliminate 2 options immediately, just using a bit of knowledge about lines, especially when they're written in vector form. So if we have a look at options B and options D. Now the direction of the 2 lines is given by this vector, okay? And I can see that these vectors are actually scalar multiples of each other. So I can see that I can write 3, negative 9, which is the direction of, iPad is playing up a little bit, which is the direction of this line here. I can write that as a scalar multiple. I can factor out a negative 3 and write it as a scalar multiple of the direction of this line, which really means that the lines are in the same direction. Now, if you think about our regular Cartesian way of describing lines, when we compare the vector form and the Cartesian form, the direction is really talking about the gradient. And what happens when we have the same gradient? It means our lines are parallel. Or it could mean something else. It could mean that our 2 lines lie exactly on top of each other. I'm going to use a different color for contrast. So we've got the green line and the blue line, and they're lying exactly on top of each other. Now, in this case, our lines never meet, and so there's no solution to, or these line segments will never intersect at 1 point. In this case, where they're lying exactly on top of each other, there's actually an infinite number of solutions when we solve them simultaneously. So this has an infinite number of solutions. This one has a 0 number of solutions. But in both cases, we don't have exactly 1 point. We don't have exactly 1 solution. So immediately we can cross out these 2. And now we just need to work out whether it's A or C. Now I'm going to get rid of this. And now we want to solve these 2 things simultaneously. Now, you'll notice that this question is a little bit cheeky in the way that it's given the lines. We need to have this scalar. I mean, it's obviously not the same as this scalar. They're different lines, okay? But they've used the same letter. So the letter itself really doesn't make a difference, except when we're trying to solve it. If it's the same letter, then we're going to be confused. So what I'm going to do is instead of lambda, I'm going to write this as mu. And I'm going to say that mu has to be between 0 and 1. Now this hasn't changed the shape of the line segment or anything, because I've just subbed out a letter for another letter, right? It's like a dummy variable. So now I want to try to solve these 2 simultaneously. Okay, so to solve them simultaneously, well, we set one equal to the other. So 1, 2 plus lambda negative 1, 3 equals 3, 1 plus mu 1, 1. And then we're going to try to solve this simultaneously and see if we can find one value for lambda and mu. Okay, so if I combine the left-hand side, that's like having 1 minus lambda, and then 2 plus 3 lambda. On the right-hand side, I have, let's see, 3 plus mu over 1 plus mu. And so we get two simultaneous equations. That's our first equation, and this is our second equation, 1 plus mu. And to solve them, I want to eliminate one of the variables. I think if I subtract the 2, it should be good. 2 minus 1 would give us 1 plus 4 lambda equals 4. So 4 lambda equals, sorry, it doesn't equal 4, equals negative 2. And okay, so here's our problem. We get lambda equals negative 3 on 4, which seems okay, except for the fact that lambda has to be positive. It's got to be between 0 and 4. So this is going to have no solutions, which only leaves us with C, but I suppose we should just check that this one does work. I probably wouldn't in a test until I come back and check my answers later. But since this is not actually a test, let's just check it. 2, negative 2. I'm going to do the same thing. I'm going to rewrite this as a lambda. Maybe you'd like to, as a mu, but maybe you'd like to see what happens if we use lambda for both of them, and you'll see that we're not going to get simultaneous equations, really. Okay, plus mu into 1, negative 3. Combining, we get 2 lambda equals 2 minus 2 lambda. Sorry, 2 lambda and 2 minus 2 lambda, and that's equal to mu 3 minus 3 mu. So we've got two equations. 2 lambda equals mu, that's equation 1. 2 minus 2 lambda equals 3 minus 3 mu. That's equation 2. Now if we substitute 1 into 2, what do we get? 2 minus 2 lambda equals 3 minus 3 times 2 lambda. Okay, let's do this all in one. 4 lambda equals 1, and so lambda equals a quarter, which checks out. It matches one of the possible values of our domain for lambda. Let's also check that mu does as well. Well, mu is 2 times lambda, so mu is going to be 2 quarters, which is half. And of course, that also matches here for lambda, or for mu. Okay, so our answer is going to be C, and that is, I think, the multiple choice. Yep. Then we start on with the short answers.